Welcome to Mr. eScience Theater presents Chemical Nomenclature, Molecular and Acidic Compounds. Molecular compounds is another way for saying covalent compounds. So covalent compounds. And a covalent compound, for example, CO2. So there's three pretty simple steps. Step number one is to name the first and second elements. First and second elements. So in this case, I would say carbon, oxygen. Step number two is to change the ending of the final element to IDE. Change the final to something IDE. In other words, carbon oxide. Change the oxygen to oxide, the IDE. And then third is to add prefixes to indicate the number of atoms, with one exception. If the first element is a single element by itself, we don't put mono for the first one. So in this case, I've got one carbon, two oxygens, so it would just be carbon dioxide. The prefixes you'll want to remember: mono is 1, di is 2, tri for 3, tetra is 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. So those are the prefixes. And again, if the first one is a single, you don't say monocarbon, you just say carbon. So let's do a little practicing here. Suppose I have N2O7. Okay? 2 nitrogens, 7 oxygens. So I'm thinking nitrogen, oxygen. I change the oxygen to oxide. Nitrogen, oxide. Now I put the prefixes di-nitrogen, hept oxide, 2 nitrogens, 7 oxygens. SO3, sulfur oxide, 3 of them, so sulfur trioxide. How about Si2S6? 2 silicons, 6 sulfurs. It's going to be disilicon hexasulfide. So again, I got the silicon and the sulfur. The sulfur changes to sulfide. I put in the prefixes di for 2, hexa for 6. CCl4. Carbon, because remember, if the first one is a lone single element, we don't put the mono. Carbon, and then 4 chlorines, change that to ide. Tetra chloride. Okay, so that's how we do it if we're given the formula and come up with the name. If we do the flip side, if we're given the name, such as bromine trichloride, it just works in reverse. Bromine is by itself, so that's just a Br, and then tri means 3 chlorides, like so. Dihydrogen monoxide, di means 2 hydrogens, mono means 1, oxide, H2O, dihydrogen monoxide. How about diiodine decafluoride? Diiodine means 2 iodines, deca means 10 fluorides, I2F10. So if I have the formula, I can do the name. If I have the name, I can do the formula. That's how you do the molecular nomenclature. So let's talk about acid nomenclature next. Acids are compounds that yield, well, there's many definitions, but for our purposes now, they're compounds that give up hydrogen or hydronium ions when mixed with water. And so there's two types of acids that we're going to be looking at right now. We've got what are called binary acids and ternary. Binary is just H plus a single element, such as HCl or HBr. Ternary are H plus polyatomic. So for example, H2SO4 is an example of a ternary because it's got a polyatomic here with the hydrogens. So in naming, when there's only two elements, it's a binary acid. Binary acids, the naming is going to begin with hydro, and then the stem, and then ic acid. So for example, HCl is hydrochloric acid, HBr is hydrobromic acid. So this is just the stem from the single element that is there with the hydrogen. Ternary acids, there's no hydro. No hydro. That's how you can tell that it's ternary. So for example, H2SO4, what we do is we have in the polyatomic ions, we have polyatomic ions that end in ate, such as bicarbonate, chlorate, iodate, nitrate, perchlorate, permanganate. They end in ate. And we have some that end in ite, like chlorite, hypochlorite, nitrite, and so on, sulfite. And so if it ends in ate, it becomes an ic. If it ends in ite, it becomes an us. So for example, H2SO4, I go to my chart, SO4 is sulfate. Sulfate becomes sulfuric acid. So sulfur, so that's the sulfate, becomes sulfuric acid. All right, let me get some more space. Hold on. So H2SO4 is the sulfate, right? Is the polyatomic here is sulfate. 8 becomes ic. That becomes sulf, like sulfate. Sulfuric acid. If I look at H2SO3, polyatomic chart, SO3 is sulfite. So sulfite, ite, becomes us. So this becomes sulfurous acid. Okay? So the key is, if it's a binary acid, meaning it's just H plus a single element, so there's just two elements here, hydrogen plus one, then it's going to be hydro, whatever the stem is, ic acid, hydrochloric, hydrobromic, hydroiodic, whatever. If it is a ternary, hydrogen plus a polyatomic, I look at the polyatomic ion. If there's no hydro for ternary, if my polyatomic ends in 8, it becomes an ic acid. If it ends in ite, it becomes an us acid. So sulfate becomes sulfuric acid. Sulfite becomes sulfurous acid. Now let's look at some examples. If I have H3PO4, if I have HClO4, if I have HI, and let's try H2C2O4. So H3PO4, I notice this is ternary because it's got a polyatomic plus the hydrogen. And PO4, I look up here, that's phosphate, so this becomes phosphoric acid. Eight becomes ic. HClO4, I look at my chart, I look for ClO4, that is perchlorate, so this becomes perchloric acid. 8 becomes ic, perchloric acid. HI, that's a binary. So that's going to begin with a hydro. Hydro within the stem here. Iodic acid. Hydroiodic. And then H2C2O4. I got to find C2O4 on here somewhere. I'm looking around, and C2O4, here it is. That's oxalate. So that's going to be oxalic acid. Again, if it's ternary, if it's got a polyatomic, it's just ate becomes ic acid, and ite becomes us acid. No hydro on the ternaries. And then on the binaries, it always begins with hydro and then becomes ic. Now, that's how we do it from formula to name. Let's look at a couple of examples of name to formula. It's the same idea. If you understand the principles, you should be good to go. So let's say I'm looking at this name, hydrofluoric acid. Okay, it starts with hydro. That means it's binary, which means it's going to be H plus the stem here. Fluor is from fluoride or fluorine, and that's going to be HF. Now, when I'm making formulas, I need to make sure I charge balance. Hydrogen is a 1 plus, fluorine is a 1 minus. It's charge balanced. It's just HF, hydrofluoric acid. Okay, how about this one? Carbonic acid. There's no hydro, so I know this is ternary. Carbonic comes from carbonate, so I got to find carbonate, and I see carbonate is here. It's CO3 with a 2 minus, so CO3 2 minus, and H is of course a 1 plus. So to charge balance, so that I cancel the charges out, I need 2 H's. So H2 CO3, that is carbonic acid. How about nitrous acid? Nitrous, notice there's no hydro, so I know this is ternary. Us comes from ite, so nitrous. I'm looking for nitrite. Look on my chart. Nitrite is NO2 with a charge of 1 minus. Hydrogen, of course, is a 1 plus, so that's just HNO2. That is nitrous acid. How about hydrosulfuric? Hydrosulfuric acid. Okay, it has the hydro, so I know it's a binary, and my root is sulfur. H is a 1 plus, sulfur is a 2 minus, H2S is my charge balanced formula. And that is how you look at the names of the covalent molecules and the acids, going from name to formula and from formula to name.